The example problem we'll be trying for the definite integral section is related to the fundamental theorem of calculus part 1. So the problem being find f prime of x for f of x equaling to the integral from 1 to x squared with 1 over t times d of t. So basically, this problem requires some of the fundamental theorem of calculus part 1. Knowing that the rule states that d of x integral h of x to g of x, f of t times d of t equals f of h of x times h prime of x minus f of g of x times g prime of x. So that's a rule we have to remember. So in our problem, we have three different sections. One is that f of t equals 1 over t. The upper limit is that h of x equals x squared, and the lower limit is that g of x equals 1. Those are the three things we have to remember. Now, after knowing all of that, we have to find the derivatives of the limits. So, knowing that h of x is equal to x squared, we can find that h prime of x equals 2 of x, just like a previous problem that I went over. And with g prime of x, we can find that it is just 0 since 1 is a constant. Now knowing all of this, we can just substitute it into the FTC Part 1 formula. So f of h of x means that we would just replace t in f of t with x squared. So f of x squared equals 1 over x squared. And knowing that f of g of x means replace t in f of t with 1. So f of 1 equals 1 over 1, which just is 1. Now we can plug all these values in, and we'll get f prime of x equals 1 over x squared times 2 of x minus 1 times 0. And as we simplify the expression, we get that f prime of x equals 2x over x squared, because when you multiply the 1 over x squared times 2 of x, minus the product of 1 times 0, which is just 0. So f prime of x equals 2 over x as our final answer.